Hey guys, how you doing? I've had breakfast now and I have caffeine, so I should sound a little more awake on this video. All right. 2.5 implicit differentiation. Now we use the chain rule as the basis of this entire thing. Remember, y is a function of x. So y is always depending on x. So remember, dy dx is the same as f prime of x. I'm going to be using this notation a lot, all right, in this section, and I'll show you why, and I'll explain why as we do it. Okay, so what is implicit differentiation? We know the big word. Let's talk about explicit versus implicit forms. Explicit equations are when it tells us exactly what the formula is for y, and we're like, if you pop this in, y is going to pop out. Implicit forms is y not necessarily solved for. I know that I want two numbers that multiply to be 1, so maybe it's 2.5, maybe it's 3/2 and 2/3, but there's no like, here's the answer, it's y on either one of these. So implicitly, y is still a function of x, even though we don't say y equals, all right? It's implicit, it's expected information. All right, so here's how we solve for implicit differentiation. Differentiate both sides of the equation with respect to x. I'm going to add on to this. When you take the derivative of the y variable, you will always have a du dx term as the derivative of the inside. All right, and I'll explain what I mean. So here we go. So we have the equation of a circle centered at the origin, radius 3, right? We recognize that. So we're going to take the derivative of each term. Now I know the derivative of x squared is 2x. It's that power rule, right? Plus sign. And I know the derivative of y. Well, the derivative of the outside, that's 2y. Y is the inside function, right? It's function of x. We don't know what the derivative of y is. So anytime we have a dy, or a derivative involving a y term, we'll have a dy dx as the inside. So this is the derivative of the outside. Y squared, y is some function, right? So it's 2y dy dx. Maybe y equals x plus 3. Whatever. It's almost like our substitution variable idea in that anytime you take a derivative of y, you'll have a dy dx. Switch back to black. So that's step one. Differentiate both sides of the equation with respect to x. So x is always the variable. When we take the derivative of y, y is a function of x. So we'll have the derivative of the inside. That should be a y, not an u. That sounds weird. Not a u. There we go. Now, we want all the dy dx terms on the left and everything else on the right. So step 2, I'm going to take my 2y dy dx equals minus 2x. So we'll call that step 1. Call that step 2. Step 3, we'll factor out the dy dx. It's already factored out. Step 4, we'll get the dy dx by itself. In this case, I'm going to divide both sides by 2y. And now I'll have negative x over y. Notice that my equation was an implicit equation, and so is my derivative. My derivative has both x and y in here. And nothing but a thing, we can deal with that. All right, let's do it again. All right, step 1. Take the derivative of everything with respect to x. So that's 3x squared. Here we have a product rule. So I'm going to take a minus and then product rule. And the product rule says, first derivative of the second plus second derivative of the first. And then we'll have a plus sign. And we'll look at our y squared term. The derivative of y squared, well, the derivative of something squared is 2 times that something, but we can't forget the derivative of the inside. And of course, the derivative of 7 on the right-hand side is 0. Don't forget to distribute this negative sign, so I'm going to rewrite 3x squared minus x dy dx plus y plus 2y dy dx equals 0. All right, so we're still in step 1. Step 2, everything with a dy dx on the left. I rearranged a little bit. I don't like to have negatives to start an equation. I lose them so frequently. Get all the dy dx's on the left, everything else on the right. Step 3, factor the dy dx out. And I'll have 2y minus x minus y minus 3x squared. And then step 4, finally solve for dy dx. And that's a negative y minus 3x squared all over 2y minus x. Or you could factor that negative out so that it's in the front. So I just factor the negative out, put it in the front. Or this negative can switch the order of the subtraction. All 3 of these answers would be completely acceptable by any homework system, and especially ours website, and should be completely acceptable for most any professor as well. Definitely for me. I like this one. It's a little quit while you're ahead type of thing. You can simplify the algebra and it makes you look awesome, and it's great practice. But if you're a point master, get the points and then work on your algebra. All right, let's find a tangent line implicitly. Ooh. All right, so anytime we see tangent line, we know that the slope of the tangent line is the value of the derivative. Always. And that's just shorthand notation for the value of the derivative because, well, we don't have an f of x here, right? We don't have an explicit function that says f of x equals this. This is implicit. But we could do this. This is just a product rule. So we have first derivative of the second plus second derivative of the first equals the derivative of 6, which is 0. We get everything with a dy dx on the left, everything else on the right, and then we'll solve for dy dx. So this is our derivative. All right, so we know that we need to find the value of this slope. So what we'll do is we'll say our slope is the derivative evaluated at, all right, so that little line, evaluated at the point -6, -1, and this equals, all right, so negative y over x, so that's a negative -1 over -6, and our slope is a -1/6, right? 3 negative signs, overall it's going to be -1/6. But we want a tangent line, so remember our tangent line is always, actually, check this out. Why don't we just add, I can't take the little bitty thing, my bad. We could instead just write this as y equals m times x minus x1 plus y1, right? Just move that over. And then this gives it to us in a form where we already have, hold on. I don't know where my cursor's at. I had to find a cursor. Sometimes you just need to curse. There we go. Sorry. Still on this problem here. In this form, we could just put our answer straight away into our homework system. Our slope is a negative 1/6. X minus a negative 1 plus. It would have been a minus a negative over here. So it will be actually a negative over here. It's just the value of y1 if we put it on the right side. There's the equation of our tangent line. Pay attention, is the y equals inside the box or outside the box? If it's already out here for you, you don't put it inside. But if it's not outside, make sure you do. Right? Equation of a line. If you use the practice it versions, it might give you the answer in the ax plus by plus c equals 0. Whether that's general or standard form is dependent on your textbook. This works just fine. Just fine. All right. And we're rolling. Solving second derivatives implicitly. And let me tell you how much fun this is. Not a bit of it. But it's not hard. It just gets to be a bit of a algebraic jungle gym. So I'm going to find dy dx. So first derivative. All right. So I take the derivative of x squared. That's 2x. I take the derivative of y squared. Remember, y is an inside function. So I take the derivative of the outside, leave the inside alone, and multiply by the derivative of the inside. And to solve for dy dx, I'm going to skip a step here. All right, we're going to take the minus 2x to the other side, and then divide by 2y, and we get minus x over y. And just like we had our original function as our starting for our first derivative, now we have the first derivative as the start for our second derivative. So now we're looking at d squared y dx squared. All right, so we take the derivative on this side. And I'm trying to decide if I want more space here or not. I don't think so. When we take the derivative of the left, right, we get d squared y dx squared. And we take the derivative on the left. Okay, so if I knew my left from my right, here's the left, d squared y dx squared. On the right, we have to use the quotient rule. And the quotient rule says low d high minus high d low all over low squared. And that just answered the question for me, really. Yeah, we're going to need more room here. Second derivative, awesome. But it talks about the first derivative here, but we know exactly what the first derivative is. So the second derivative is negative y plus x times, what's dy dx? dy dx is negative x over y, all over y squared. The calculus isn't hard. We finished calculus here, and then we did some algebra. And then we did some calculus here. And now we're just doing some algebra. And my y's, I realize my y's are looking a little weird. That is a y as well. All right. Let's do a little side work over here. We have a minus y plus x over 1 times a minus x over y. So this is over 1 also. So let's call this a minus y squared over y minus, right, positive times negative is minus x squared over y, which is a negative x squared plus y squared all over y. So I'm going to put that over here. Our new numerator is minus x squared plus y squared over y, and that's all divided by a y squared, which gives us a final answer of d squared y dx squared. That y comes down. We'll have a negative x squared plus a y squared over y cubed. Second derivative implicitly. The most important part is right here as we substitute our derivative in for the dy dx as we get to the second derivative. Whew, that was fun, wasn't it? Remember, if you need me to slow down, you have a pause button. Pause. Don't you wish you had that in class? All right. We're going to find the derivatives of each function implicitly. Here we go. All right. Just derivative implicitly. Anytime you see the derivative of y, y is a function of x, and so we have to have the dy dx as the inside. So the derivative of 2x cubed, 3 times 2 makes 6, x, 1 less power, x squared. 3y squared. All right, that 3 is going to hang out. The derivative, I said y squared. My goodness. It's a day already, and it's only 9 a.m. So we'll have 3 times 3, which is 9. Y, subtract 1, right? 9y squared times the derivative of the inside. Because I took a derivative that involved y, I have to have dy dx, and that equals 0. So we'll have 9y squared dy dx equals a minus 6x squared, and dy dx equals minus 6x squared over a 9y squared, and we will rewrite that simplified version of minus 2x squared over 3y squared. Isn't it amazing when the pen works right? I love this. I'm gonna do better in class. I am gonna not use the school computers, I think. All right, let's just switch it up just for something new. Find the derivative. You'll find that these are all very, very similar. The derivative of x to the 5th is 5x to the 4th. The derivative of y to the 5th is 5y to the 4th times dy dx. Now, equals 0, right? Derivative of 16, derivative of any constant is 0. Why do we put a dy dx but not a dx dx? Well, the derivative of x is 1. So we kind of are taking the derivative of x with respect to x as well. We're just multiplying by 1, and you know, mathematicians are kind of lazy. So we don't have to worry about that. It's already explicitly in terms of x. We don't have to worry about the implicit, the implied function on the inside. Solving for dy dx, we'll subtract our 5x to the 4th and then divide by 5y to the 4th, and we'll call this a negative x to the 4th over y to the 4th. 5s cancel each other out. Man, my boxes have been pretty good today too. I haven't even ruined the work. I don't know. I don't think you can handle this as amazing as I'm doing right now. I'm just kidding. All right, let's give ourselves some space here. This is ugly, and this is not happiness. This has some product rule going on. Derivative of the constant 0. So let's take these individually. The square root of xy. Okay, so I see a chain rule where the inside is xy and the outside is the square root, or the 1/2 power. The derivative of the inside, I have to use a product rule. It's first derivative of the second. That's a dy. Oh my goodness, just erase it. Why do I try to make it better? Dy dx, first derivative of the second plus second derivative of the first. And the derivative of the outside is 1/2 to the negative 1/2. So the derivative of the square root of xy part is derivative of the outside. No, that's not where I want it. I'm going to need that for scratch work. So the derivative of the square root of xy is the derivative of the outside leave the inside alone, and then multiply by the derivative of the inside. All right, equals. Now let's take a look at our x squared y, right? We have a product rule where our first is x squared and our second is y. The derivative of the first is 2x. The derivative of the second is dy dx. So our derivative is first derivative of the second plus second derivative of the first. And the derivative of 1 is 0. So I'm going to kind of put my scratch paper over here on the side. So each of these parts, if you need to do it separately, do it separately. Do it separately. And now we're going to do a lot of algebra. The unfortunate part of calculus really is everybody thinks calculus is hard, but it's, like I say every day, it's the algebra. So take it slow, right? You've got the calculus. You could do the calculus. Let's make sure we can all do this algebra. 1 over 2 square root of xy times x dy dx plus 1 over 2 square root of xy times y equals x squared dy dx plus 2xy. All right, so I distributed my derivative of the outside, leave the inside alone, to each part of the derivative of the inside. Now everything that has dy dx, I'm going to take to the left. So I'll leave this one here. Actually, here's what I'm going to do. I'm going to make it a little bit easier to look at. 1 times x is x, and then I'll put the dy dx here. I'm going to subtract my x squared dy dx. I have my 2xy on the right, and I will subtract this term, which is minus y over 2 square root of xy. Okay, so little negative exponent gets frustrating after a while, so I took it back to a radical form and distributed. Second step, I combined. When I multiply 1 times x, I got x, and then dy dx. Here again, when I multiplied times y, y is in the numerator now, and I take it to the other side. When I factor out a dy dx, all right, I'm running out of room. Follow this, if you will. Please follow this. 2xy minus 2 over the square root of xy. All right, that's my right side. And if I factor out the dy dx, what am I going to be left with? I'm going to be left with these terms. X over 2 square root of xy minus x squared. All right, when I factor out the dy dx, the fraction minus x squared becomes the coefficient of dy dx, so that becomes our denominator. Now, this could absolutely be simplified, and I would probably simplify it as such. I would multiply both the numerator and denominator by 2 over the square root of xy. It'll cancel here. But it still gets multiplied times the first one. All right, so I'll have 2xy times 2 square root of xy minus y all over the 2xy cancels out, 2 square root of xy, x minus 2x squared square root of xy. And collect that, call that a 4xy. You can factor out the y if you want to. Here you can factor out an x. I'm done. That's enough algebra for a calculus class. Remember, this is all the calculus right here in our side notes. That's the calculus. The rest of this is algebra. Go slow, stay organized, and try not to skip steps like I did just because of paper. Remember, timber industry is going strong, and we will make more paper. We're growing new trees every day. All right. Y equals the sine of xy. Oh, my head. Think about what that says. I can't get that point, can I? There you go. Boom. Okay, here we go. On the left, the derivative of y, that's just dy dx. On the right, let's change colors. Let's go back to purple. So we're looking at the sine of xy. I'm going to let this be u. So we're looking at the sine of u. And we know that the derivative of the sine of u is cosine of u du. So here's our u, and the derivative of u is first derivative of the second plus second derivative of the first. So if we have the sine of xy and we want the derivative, this will be cosine of u du. Hey, it's time for class. Sorry, that's my alarm. In 15 minutes, I'm not going to be in the classroom. All right, so the derivative of cosine u du, so we come back over here, the derivative of sine of xy. This is, the derivative of sine is cosine. Leave the inside alone, and then multiply by the derivative of the inside. Another thing to keep in mind here, this x does not cancel with this x. Remember, the d dx is an operator. All right, it's a surgeon. It operator. So if you have a d and a d, you got to have the x if it's going to be there. You can never cancel this x or these d's. All right, it's an operator. It's like a plus sign. I don't need two of them. Let's just take away one of the lines. It doesn't make sense. But now we're going to distribute our cosine. So we'll have dy dx equals x cosine of xy dy dx plus y cosine of xy. I want all my dy dx terms on the same side. So let's subtract the x cosine of xy dy dx from both sides. I'll give us a little more room here. Factor out the dy dx. I'm not going to be lazy this time. I'll actually write it down. Remember, when we factor out a d, this is a y. When we factor out the dy dx, we have to have that 1, because dy dx divided by dy dx, really, that's what factoring is. It's just dividing but keeping it there. We have to have a 1 placeholder minus the x cosine of xy equals y cosine of xy. And finally, we get to our answer. Dy dx equals y cosine of xy over 1 minus x cosine of xy. Now, if this 1 minus wasn't here and we just had y cosine of xy divided by x cosine of xy, those cosine of xy's would absolutely cancel out and we'd have y over x. But that's not our problem. Our problem has the 1 minus, so we leave it right there, and all is right with the world of calculus. All right, slopes and tangent lines and some second derivatives. I have a feeling this would have been a long one had we done it in class. Probably would have had to finish with a recording anyway. So, definitely, this one will take 2 days in the future. Find the slope of the tangent line at the given point. Remember, slope of the tangent line. My slope is going to be, my phone just turned on and is doing weird things. I don't know what's going on. I think Google's listening to me. The slope of the tangent line will be the value of the derivative at the given point. All right, so we need to find that slope value. In order to find the slope value, we find the derivative. All right. Chain rule. Chain rule says derivative of the outside, leave the inside alone, multiply by the derivative of the inside. On the right-hand side, they're individuals. It's so much easier. X cubed has a derivative of 3x squared, and y cubed has a derivative of 3y squared dy dx. Excuse me, my puppy's having a nightmare. I gotta handle it. Can't have puppy nightmares on a recording. Okay, so here we see this dy dx. It's all sorts of parentheses. So we have something, and then we're going to distribute it. And we're going to distribute it very carefully. We'll have 3, the quantity of x plus y squared times 1, and then, plus sign, we'll have 3 times the quantity x plus y squared times dy dx. Equals 3x squared plus 3y squared dy dx. Remember, this step, that's the calculus. I mean, knowing that we need to find this value, we're kind of still doing calculus, but it's a lot of interim algebra to get there. So we get all our dy dx's on one side. No, it doesn't matter which side. I just always take him to the left so that I don't have to make decisions. I like to make a decision once and then stick with it for a lifetime. 3x squared. And that's not true. I actually am fairly open-minded and willing to learn as I get older. But in this one, I always take it to the left. Factor out the dy dx. When I factor out the dy dx, right, what's left over is going to be my denominator. So this is 3x squared minus 3 times x plus y all squared over 3 times x plus y all squared minus 3y squared. Whew, that's not so bad. But now we want to evaluate that at negative 1, 1. So everywhere you see an x, put a negative 1. The coolest thing is right here. Negative 1 plus 1 makes 0, so that's going to go away. And so is this one. So negative 1 squared is 1. 1 times 3 is 3. Negative 1 plus 1 is 0. 0 squared is 0. 0 times 3 is 0. And when I subtract 0, I still have 3. Again, we're going to get a 0 minus 3. So our slope is minus 1, which tells me the equation of our oh, it just says find the slope. We're finished. Woo! I thought we needed to find the equation of the tangent line. That would have been much more work, and not a lot more work. So our equation is y equals negative 1 x plus 1 plus 1. So if we wanted the equation, it's kind of a little bonus right there. This is the only number we cared about. We cared about finding the slope. I haven't hit save at all. So I'm going to hit a save button here. Hopefully it does. Oh yeah, it saves quicker than the campus machines. No shade, but you know, shade. All right. We want to find the slope of the tangent line. No problem. Remember that the derivative of the tangent of u is secant squared of u times du. Look that up in the chain rule derivatives if you need to. So the derivative of tangent, okay, so our u is going to be x plus y, and our derivative of u will be 1 plus dy dx, right? Fantastic. So the derivative of tangent is secant squared, leave the inside alone, and then multiply by the derivative of the inside. The derivative on the right-hand side, derivative of 0 is 0. Now, there's a lot of zeros going on here. Now remember, it's not the x plus y that's being multiplied by the 1 plus dx, the dy dx. It's all of secant of x, secant squared of x plus y being multiplied. So I'll have a secant squared of x plus y times 1 plus the secant squared of x plus y times dy dx equals 0. This is a secant squared of x plus y dy dx equals minus a secant squared of x plus y dy dx, I'm getting nervous, is minus secant squared of x plus y all over a secant squared of x plus y, and that's always -1. Because it doesn't matter what the point is. 0 plus 0, the secant of 0 is, secant is reciprocal of cosine, so that's 1. So I'll have -1 over 1. But it doesn't matter. If I have the same thing in the numerator as I do in the denominator, it's always going to be a 1. That point doesn't matter. That's crazy. I want to see this graph. I'm curious. Something seems off. Yeah, I don't know. I just randomly showed a bunch of stuff there. That's not what I want. I want Desmos. Desmos, tangent of x plus y equals 0. Look at that. That's our graph. And what is the slope? The slope is always -1. It looks like maybe this isn't the graph. Like, even Desmos doesn't like it. I'm feeling better about our answer. I'm feeling much better about that answer. The slope is definitely always negative. It's going down. -1's the slope. Shoot, we'll take that. Let's not do that. Let's go down here. Okay. I don't like that. There we go. That's what I was looking for. Let's see if I grab that point, make it go away. Nope, it'd be easier to erase it. There we go. All right. It's a recording. I'm sorry. You got to pause this if you need to. Can you imagine me doing this in the class in 50 minutes? We would have had like 10,000 questions by now, which you absolutely legit should be asking. So we're going to have a really good week next week of answering questions, going over problems, taking care of it all. All right. I see a product rule. A product rule where my first is x squared plus 4, and my second is y. The derivative of the first is 2x, and the derivative of the second is dy dx. All right, we can find the derivative. So the derivative of this is first times the derivative of second plus second times the derivative of first equals sign. Derivative of 8 is 0. So I'll have dy dx times x squared plus 4. I have no idea why I switched sides on that. Equals a minus 2xy. We'll take dy dx, and that's minus 2xy divided by x squared plus 4. So we can find the derivative. No problem. But we also need to evaluate it, right? We want to find the slope of the tangent line. So to do that, we'll take dy dx, evaluate at the point 2, 1. So that's a minus 2 times 2 times 1, right? xy, over x squared plus 4. Negative 2 times 2 is negative 4. Negative 4 times 1, still negative 4. 2 squared is 4. 4 plus 4 is 8. And my slope is a negative 1/2. Slope of the tangent line. Whew. Just a couple more. We're almost there. Oh, literally 2 more. One more of finding the... Woohoo! There we go. Just forgot a little shift there. There we go. One more, finding the slope of the tangent line using implicit differentiation, and then we'll find a second derivative because those are so much fun. All right, here we go. Chain rule. Chain rule, where the inside is x squared plus y squared and the outside is squared. The derivative of the inside is 2x plus 2y dy dx, right? Anytime you take the derivative of y, there's a dy dx. And the derivative of the outside is 2 something. All right, so the derivative of the left-hand side is the derivative of the outside. Leave the inside alone. Yeah, I should never make my parentheses first. Derivative of the outside, leave the inside alone, multiplied by the derivative of the outside. Equals. All right, now on the right-hand side, I've got a product rule. And you can take this in several different ways. I'm going to take first is 4x squared and second is y. I could just leave the 4 as a coefficient and then you do product rule on the x squared y, but this way I don't forget about it. And we also see kind of how it's used. Derivative of first is 8x and derivative of second is dy dx. Remember, you don't have to write these down if you don't need it. If you can look at this and say, oh, it's going to be 4x squared times the derivative of y, right? First derivative of second, plus second derivative of first. Maybe you don't need this. Maybe you can just write it down. That's fantastic. That's my goal for everybody. I'm going to write a simplification step kind of as we distribute. Clean this up a little bit. So we'll have 2 times 2, which is 4x times x squared plus y squared plus 4y times x squared plus y squared dy dx equals 4x squared dy dx plus 8xy. Little scratch paper work over there. Yep, that's too bad. There we go. So let's move everything with the dy dx to the left. Yeah, that's not it at all. I mean, it is, but it's not. So we have our 4y x squared plus y squared dy dx minus 4x squared dy dx. We have an 8xy already on the right, and we will subtract 4x times x squared plus y squared. Remember, when we factor out our dy dx, Everything on the right is in the numerator. And I just don't feel like distributing here. X squared plus y squared is that nice little package. Kind of came to us. So I leave it as often as I can in hopes it'll cancel out. It's not going to. In the denominator, right, we have our coefficients of the dy dx, because if I factor it out, that's what I'll divide by. So we have 4y x squared plus y squared minus 4x squared. Now we want to evaluate at 1, 1. So everywhere there's an x or a y, put a 1. That's 8 times 1 minus 4 times 1 times 1 squared plus 1 squared all over 4 times 1. 1 squared plus 1 squared minus 4 times 1 squared. 1 squared and 1 squared. 1 squared is 1. 1 and 1 is 2. 2 times... Are you serious? It's undefined. And that hurts my heart. It's undefined. We got more work to do. Looks like we can factor out a 4. Looks like we can factor out an x. Alright, no we can't. Can't take an x out of... Friends. No. We'll talk about this one in class next week, because I'm not doing any more work on that. I'm just not going to. I'm not going to. And I'll be quite honest, I think that's probably enough on your brain for today. Definitely enough on your brain for today. Thanks for sticking with me. This video is out of control. It's like the whole length of a lecture, of an actual class, and I am super sorry for that. But implicit differentiation is going to be huge, starting the week of the 21st as we talk about related rates. So absolutely go slow, take your time, write your steps, and we'll work on this more together when we're back in class on Monday. Your exam review should be open. Remember, that is a homework assignment. Get it done, turn it in, get some good points, and get ready for your exam at the same time. Thanks for your patience. Thanks for sticking with me. I hope you have a fabulous weekend. Be safe if you're partaking for the Super Bowl, and make sure you come back to me happy and healthy. Okay, you don't have to be happy. I'm not going to force you to do that, but I'd really like for you to be healthy when I see you again. Laters.